Hello everyone, happy to see you here. Today we have great and quick algebra question. We know that the sum a plus b equal to 14 and a product a times b equal to 20. We need to solve this question for a and b, so right now you can easily pause the video and write your solution in the comments below. It will be really interesting to check your answers in the end of the video. So right now let's start. First of all, we have two equations, and I want to look closely at this first equation. Let's express from the first equation, let's express our b. So this is our first step. So from the first equation, b equal to 14 minus a. 14 minus a. And right now let's plug in this b. Instead of this b, let's plug in 14 minus a to the second equation. So let's do it. So we have a, and instead of b, we have 14 minus a. Okay, so 14 minus a equal to 20. Right now, let's simplify it. We can easily multiply our a by these parentheses. So let's do it. So we have 14a minus a square and equal to 20. And if we look closely, like from a different angle, this is a quadratic equation, but we prefer a little bit different order. Yeah, we prefer minus a square on the first position. So let's do it. So minus a square on the first position. On the second position, we write this plus 14a, so plus 14a, and minus 20 from the right side. So minus 20 from the right side equal to 0. And the final tricky move, my quick recommendation, because we prefer multiplying both sides by minus 1. So we prefer changing the signs to the opposite one, because we prefer this a square without this negative sign. Okay, it's much easier for us to simplify. Okay, so a square, and then I think minus 14a and plus 20. So this is like a quick trick. I really hope you learned this trick at school. So we just multiply or divide both sides by minus 1, and then we will basically eliminate this negative sign from here, and we have a positive. So we have a classic order of signs. Okay, right now we have a basic quadratic equation, and of course this is up to you how you prefer solving this type of question. For example, let's write our coefficients quickly. Let's write our a equal to 1, b equal to minus 14, and c equal to 20. So we have our coefficient and we know our formulas. Let's start, for example, with discriminant quickly. We have discriminant equal to b squared minus 4ac, so equal to b squared, so minus 14 square minus 4 times 1 and times c equal to 20. So let's simplify it. Minus 14 squared, this is our table case, 196 minus 4 times 20 equal to 80. So our discriminant is equal to 116. And this is really great because discriminant is greater than 0. So from here it implies that we have two roots. And moreover, we can say that we have two real number roots and we have two pairs of solution. This is our first thought. Okay, what are we going to do next? Right now, let's write our a first and a second. So let's find our roots, because this is only our discriminant. Yeah. So let's do it. So 1 second. Yeah, like that. Yeah. So we have minus b plus minus square root of discriminant and all over 2a. Okay, all over 2a. So right now let's plug in everything. We know everything from here. So minus b minus 14. So minus 14 plus minus square root of discriminant square root of 116. And all over, we're going to divide all of this by 2 times 1. So equal to, right now, minus 14 equal to 14. Plus minus square root of 116. Let's write it like that without any changes. So square root of 116 and all over 2. And right now, a few thoughts about this 116. So this is not a table case, but let's do really interesting and quick trick. So 116 right here, we divide by 2. So if it's not a table case, my quick recommendation is to divide it step by step by 2 or by 3. So let's divide it by 2. We have 58. Let's divide it by 2. We have 29. So basically, we can express this 116 like that. So we have 14 plus minus square root of. We're going to express this as 2 times 2. We have 4. So let's write it like 4 times 29 all over 2. And right now, a square root of a product equal to a product of square roots. So we can split it. We can write it as plus minus square root of 4 times square root of 29. And right now, from this angle, square root of 4 equal to 2. So as a result, we have 14 plus minus 2 square root of 29 over 2. And our last step, of course, there are two ways. How can we do that? We can factor 2 from our numerator, or we can write this one as 14 over 2 and this one over 2. So basically we can cancel everything by 2. So we have 7 plus minus 2 square root of plus minus square root of 29 without 2, so square root of 29. So this is our answer. But one really interesting thing right here, we have two roots. So this is our a first. Let's write with the positive sign. So 7 plus square root of 29, and we also have negative 1. So a second equal to 7 minus square root of 29. But this is not our answer. This is not our pair, because in the beginning we had our b as well. So b equal to 14 minus a. So right now let's solve it for right here. Let's solve it for b first. So b first equal to 14 minus a first. So 14 minus a first. And right here b second equal to 14 minus a second, yeah, like that. And right now let's plug in everything. So b first equal to 14 minus a first, so 7 plus square root of 29. From here we have b first equal to 14 minus 7 and minus square root of 29. So basically we have absolutely the same answer in terms of coefficients. So we have 7 minus square root of 29. We have a symmetrical pair. We have 7 plus square root of 29 and 7 minus square root of 29. And using the same logic, we can solve it for b second. But basically, we have absolutely the same thing as right here. So b second will be equal to 7 plus square root of 29. But maybe a lot of students don't trust me. So let's do it like that. So 14 minus a second equal to 7 minus square root of 29. So basically b second equal to 14 minus 7 and plus square root of 29. So from here 14 minus 7 equal to 7. So b second equal to 7 plus square root of 29. So basically we have two pairs. So I want to write it as the full answer and then we will check it. So our answer to this question. So we have first pair, not like a first, a second, but our pair looks like that, a first, a second. So we have 7 plus square root of 29 and 7 minus square root of 29. And another parenthesis, 7 minus square root of 29 and 7 plus square root of 29. So right now let's check it. So we have our answer. So right now let's check it. Let's prove our answer. First of all, I'm gonna write our question from the beginning. So a plus b equal to 14 and ab equal to 20. And right now one really interesting trick, because we have addition and multiplication. So basically we don't need to check both of these parentheses. We need to check only, for example, this one or this one, because a plus b equal to b plus a. It doesn't matter what we're gonna add to this or this expression to this one or this to this. We have absolutely the same thing because we have a symmetrical pairs, symmetrical answers, and the same coefficients. So first of all, let's check real quick our addition. So a plus b equal to, so 7 plus square root of 29 plus 7 and minus square root of 29. Right here we're going to cancel this square root sign. 7 plus 7 equal to 14. So basically we have this thing right here. So a plus b equal to 14. Absolutely correct. Correct expression. And in the end, let's check real quick our multiplication. So we have a times b equal to, so 7 plus square root of 29 and 7 minus square root of 29. And one really interesting moment, of course you can multiply parentheses by parentheses, but right here we have difference of squares. I hope you remember this formula from school when we have like x plus y, x minus y. On the left side we can write it as difference of squares, x square minus y square. This is a classic school identity. I hope you understand it. So this is our difference of squares. 7 square minus square root of 29 to the power 2. And from here, this is equal to 7 square 49 minus, right here we can cancel it, 49 minus 29 equal to 20. So expression that we exactly need on the left side. And this is our answer. This is our answer to this question. Our answer is absolutely correct because we check it, we prove it right here on the bottom. So I really hope you understand it. But if you still have any question, write a question in the comments below. It's a classic, easy question from the beginner level. Sometimes I see this type of question on entrance examination, you know, and this is a classic question for beginners. And of course, if you're studying math, if you have problems with math, this is really great question to practice quadratic equation, to practice algebraic skills, to practice different identities. Very classic and basic question. So thank you everyone for your time. Take care of yourself. Have a great day. Write your thoughts about it. Write your notes. What do you think about it? Write your response in the comments below. It will be really interesting to read about it. So thank you everyone for your time. Take care of yourself and have a great day. See you in the next videos.